Hey guys, welcome back. So this week we're going to continue working on factoring. We learned a little bit on factoring last week, but with a greatest common factor. So you saw things that looked like this, what I wrote up at the top in blue, and we would look at it and see what is the greatest common factor from both that we can take out. And when I say take out, I mean divide by both. And let's actually do this problem just as a review because it's going to be helpful moving forward to the rest of factoring. If I look at 10x squared and 5x, let's just start with the number 10 and 5. What's the biggest number that I can divide into both of these? And that number would be 5 because 10 divides by 5 and 5 divides by 5. So I'm going to take out a 5 and I'm going to write that over here. And what about the x's? In the first one I have an x squared and in the second one I have an x. So I can take out one x from both of them. And then what would be left? Well, in the first term, 10 divided by 5 is 2, and x squared divided by x is x. In the second term, 5x divided by 5x is just 1. So after you have factored, after you've taken it out, what's left in your parentheses is just 2x plus 1. So that is one type of factoring called factoring by the greatest common factor. And that's when things, your terms here and here, when they have something in common that you can divide out, you do divide it out to make it whatever's left in the parentheses more simple. So let's look at another type of factoring. And what's going to be helpful is to just review how we multiply binomials before we get into that. So let's look at this first example. I'm asking you to multiply two binomials. Remember, it's called binomials because there are two terms in each one. So notice in the x and in the first term, x plus 1, x and 1 are each a term. And in the second one, x plus 5, x and 5 are each a term. So this is a binomial and this is a binomial, and we're going to be multiplying them together. Okay, so remember what you do is you take the first term and you multiply it to everything in the second one. So let's do that. X times x is x squared, and x times 5 is 5x. Then we take the second one, which is just the number 1, positive 1, and we're going to multiply that to both things. So what do we get? X plus 5. And then we just combine together any like terms that we can combine together. So 5x plus x, these are the ones that can be combined together. And in total, that would be x squared plus 6x plus 5. Okay, let's do the next one. So I'm going to take this variable m, I'm going to multiply it to both things. That gives me m squared plus 6m. And now I'm going to take this negative 4 and do the exact same thing. So that'd give me negative 4m minus 24. And then combine together anything you can combine together. I can combine these together, and in total that gives me m squared plus 2m minus 24. Okay, so now I'm going to erase the screen from the work we did, and I just want to compare the original binomials to the answer that we ended up getting. And there's going to be a pattern here, and that pattern is going to be what we're focusing on all week long, and that's what we're going to be calling factoring trinomials. Okay, so let's try and figure out this pattern. I'm noticing that these numbers right here, 1 and 5, they add to get me to 6, and they multiply to get me to 5. So that's interesting. Let's see if that's true in the second one. Negative 4 and 6, that adds to get you 2, and that multiplies to get you negative 24. And that is going to be the pattern that we're going to focus on moving forward for factoring. So if I had just showed you, let's pretend that you did not know that this was the binomials that it came from. What if I just showed you this and I asked you to go backwards? Well, you could use that pattern. You could say, well, I know that I have to have numbers that multiply to give me 5 and add to give me 6. I'll write that in again. And then you would say, okay, well, what multiplies to get me 5? Well, my only options are 5 and 1. And those work because they also add to get me 6. Okay, so that's going to be the really, really important pattern that you have to remember going forward. When I ask you to factor something that already looks like this, you need to find numbers that multiply to get you the last number here, and that add to get you this middle number. Okay, so let's practice that with an example. And by the way, just standard form, you'll see me talk about like B and C, and you might wonder what that is. Standard form is this. what I wrote at the top of the screen in green. So it's just the first number we call A, and the second one B, and the third one C. Okay, so we need to, just like we said on the last screen, I need to find numbers that multiply to give me the last number and that add to get me that middle number. So let's just start by finding numbers that multiply to get me 12, and I'll write them out to the side. So what are factors of 12? Well, I could start with 1 times 12, 2 times 6, and 3 times 4. There are no other factors of 12. So then we just have to pick, okay, well, which of these three options, I have only these three choices of numbers to use, which choice adds to get me to 7, which is the middle term, our B term? Okay, well, 1 and 12, that won't work, because if you add them, you'll get to 13. And you can also think about both of those being negative as well. What if it was -1 and -12? Because a negative times a negative is still a positive, so that would work for factors of 12. So when I write this list out, keep in mind that both these numbers could also be negative, and that would still work. So let's think, is -1 plus -12 equal to 7? No, it's not. So option 1 is out. Okay, let's look at option 2. 2 and 6. Those add to give me 8, and if they're both negative, it'd be -8. And that's not 7, so that does not work. And the last one, which is probably obvious all along, 3 plus 4 does add to get me 7. So then I can fill it in like this. X plus 3, X plus 4. Those must be the binomials that this came from. And sometimes people ask, like, does it matter if I write this first, or what if I'd flip-flop them? And the answer is it doesn't matter at all. It doesn't matter which one you write first, because we're just multiplying. So how could you check your answer? Well, we could always just multiply it back out and double check that we got the original answer. Sometimes, remember, this is called foiling. So I'll take the first term, x, and multiply it to both things in the second binomial. And that gives me x squared plus 4x. This is exactly what we did on the last screen. Then I'll take the second term, 3, and multiply that to both things. That gives me 3x plus 12. Then I'll combine together any like terms. 4x and 3x gives me 7x. So in total, I have x squared plus 7x plus 12, which, if you look at the top of your screen, is exactly what we started with, so I know I did it correctly. So my final answer, although I've written all over this page now, is this right here. When we say factor, I just want to see those two binomials. Anything afterwards that you do, like all of this, is just me checking my work. Alright, so let's do some practice problems of those. Remember, in each one, my first step is to list the factors of that last number. So let's look at 16. What are some factors of 16? Actually, I'm going to write it on the other side. And by the way, I have your steps written over here in case you forget them. So what are factors of 16? Well, obviously 1 times 16, 2 times 8, 4 times 4, and that's it. So now I just have to look at those and see which ones will add to get me to 10. And it should be pretty obvious. The only ones that will work will be this 2 and 8. And they're both positive, 2 plus 8, both 8 and 2 being positive numbers. So I'll write it like this, x plus 2, x plus 8, in parentheses. Again, it wouldn't have mattered if I wrote it like this, x plus 8 first, and then x, oops, let me erase this last one. So if I wrote the x plus 8 term first, or the x plus 2 term first, it doesn't matter. And that's it. That's my final answer. I could, of course, check by taking the first term and multiplying it to the both terms in the second binomial, and then doing the same thing with this one here, and just checking that it works, but I know this one's going to. Alright, let's look at the second one. What are factors of 20? Well, I have 1 times 20, 2 times 10, 4 times 5, and that's it. So let's look at these numbers and say which ones will add to get me to 9. And the only one that would work would be 4 and 5, 4 plus 5. So I'll write n plus 4, n plus 5. And we're done. I factored it. Remember, what this means is that I could always FOIL it back out, so take the n and multiply it to both, and take the 4 and multiply it to both, and you would end up getting the exact same thing that we started with in the beginning right here. Okay, I want you to, actually I'll do the third one with you and then I'll have you pause the screen and try the last one on your own. So let's write out factors of 24. So we have 1 times 24, 2 times 12, 3 times 8, 4 times 6, and that is everything. So we have 4 options here. And which ones will add to get me to 10? And you might think that there's 2 options here, because I could do 4 plus 6, which obviously adds to get me to 10. But some of you might think, well, what if I did 12 and then minus 2? That also adds to get me to 10. But just think, if the 2 was a negative, then these would not multiply together to get you positive 24, which is what this list is anyways. So this whole list is numbers that multiply to get me to positive 24. Well, if one number is a negative, then it's going to multiply to be negative 24, which is not what we want. So that's not an option, because it was not a factor of positive 24. So we're going to use positive 4 and positive 6. So my answer would look like this. Okay, so try the last one on your own. Write out factors of 1. That should be really easy. And make sure that you choose the ones that add to get you to 2. And again, that should be really easy. Alright, let's check. Factors of 1. The only thing you can do is 1 times 1. And obviously that adds to get you to 2, so that's our choice. So we'll write it like this. Y plus 1, y plus 1, and you're done. If we were to multiply this back out to check our answer, we would get the exact same thing that we started with in the original, so we know we're good to go. Alright, and that's it for today's video, you guys. It's just factoring trinomials, making sure that you have found numbers that multiply to get the last number and add to get the middle number. And if you have that, then you are all good to go.